cover plates which is having different thickness. In the last problem, the plates are having same number of thickness, that is 20 mm. But in this case, one plate is having a thickness of 18 mm and another plate which is much smaller, and it is 10 mm plate. Both the members are being connected by a cover plate which is having 6 mm thickness at top L as well as at the bottom. And whenever you are connecting with the plate, you should provide a packing plate. What is the purpose of packing plate is, if the two plates are of different thickness, the packing plate will be having the rest of the thickness. See, if it is 18 mm thick, if your plate is 10 mm, rest of the 8 mm will be packed by this plate. Two cover plates 10 mm and 18 mm thick are connected by double cover butt joint using 6 mm cover plates. This is what it is given. Find the strength of the joint. You already know that how to find strength is, you should find strength of bolt as well as strength of plate. What is the least value which is taken as the strength of the joint? You have to find these things. Given M20 bolt of grade 4.6 and FE 415 plates. These are the given data. Now you have to check that either the strength for the given design is sufficient or not. All the detailings are given. The edge is 40 mm, the pitch is 60 mm. Both the things are given. Gauge, which is also given as 60 mm. You totally have 6 plus 6, that is 12 number of bolts. If two number of, that is 18 mm and 10 mm plates are given, you should take the lesser plate size and then design and then check the strength. This is known as tacking rivet for packing plate and the main plate which is being connected by this packing rivet. So this you should not consider. You can observe that there are 5 number of bolt in this section. One is known as rivet, they have given in the figure, and this should not be considered for design. A packing plate which has 8 mm thickness is to be used, hence shall be reduction in the shear strength of the bolt by a reduction factor. In the code book they have given this class shear strength of the bolt 10.3.3. in that you have this formula. Can you find this formula? BPK, that is beta PK. What is that? Packing plate constant. PK is packing plate and beta is a constant. How to find that? 1 minus 0.00125 T PK. That is what you mean by T? Thickness of packing plate. What is the thickness of the packing plate? 8 mm, and this has to be substituted here. If you substitute that, you will be getting a constant of 0.9. If any packing plate is provided, it reduces the shear strength of the material. Due to this packing plate, the strength capacity reduced by 10%. That is, only 0.9% will be carried, 10% is left out. Why? Because due to this packing plate. And your shear strength formula reduced to this. You already know this formula, FUB. What is the shear strength formula? FUB divided by root 3, 1 into pi d square by 4 plus same 1 into 0.78 pi d square by 4, which is nominal dia at shank and at the thread. You know this. Here they have added this formula. Why? Because when you are providing any packing plate, it should be substituted here and this constant will be here. Now you find the nominal strength of a single bolt. How will you find? You have this formula, substitute N as 1 at both the sides. Answer is 116.228 kilonewton. One bolt carries 116 kilonewton of force. How many bolts are here? 6 number of bolt in a joint. In a single joint you have 6 numbers and you multiply this. So this value will be divided by 1.25. Why? You will be finding design shear strength. So this value has to be divided by 1.25. In the class you will be having the formula gamma MB. So this gamma MB is 1.25, you will be getting 92.9 kilonewton, and this is for single bolt in the sense you have to multiply into 6. Your answer will be 557.896. So this is the strength of bolt, that is shear strength. Next you have to find bearing strength of bolt. Edge has 40, 40 divided by 3 into 22, pitch. What is the pitch? Which is 60. So 60 divided by 3 into 22 minus 0.25, FUB, which is ultimate strength of bolt 400, ultimate strength of plate 410. What is the least of the value? What is 40 divided by 3 into 22? 0.606, yes. Then 60 divided by 3 into 22 minus 0.25, 0.659. Okay, then it is greater than 0.6. The next value will be around 0.9. 400 divided by 410 will be 0.97. So eventually the greater will be first case, that is 0.606. Now you substitute 2.5 into kb as 0.6061. D is diameter of the bolt, which is 20. What is T? T is thickness of the plate. You have two number of plates. Which plate you will take? Least thickness of the plate. Why? Because when a force is being applied, the greater thickness will not fail first. The lesser thickness object will fail first. So when you are checking the strength, take the least strength, that is T equal to 10 mm. Fu is 400. Now you substitute all the things, you will be getting one answer. 124.25 kilonewton. Now what is the design strength of the bolt? And whatever value you are getting divided by gamma MB, 99.4 something you will get, 99.4, the 98, you round it off as 99 kilonewton. This is for a single bolt. For 6 number of bolt you have to multiply into 6. So 6 into 99 will be 596.4 kilonewton. Now which is greater? Either shear strength is greater or bearing strength is greater. See, bearing strength is now greater, the shear is very less. So your design strength will be what? You will be designing and taking the strength of the joint as least only. What is least? 557. The strength of the bolt connection is 557.8 kilonewton. Always the strength of the plate in the joint equals strength of the plate at weakest section. Okay, next find the design strength of plate. Now bolt is over. Now find the design strength of plate. What is the formula? 0.9 AN into FU divided by gamma M. AN is net area. So what is your net area here? If you take any section, this is the section. What is the breadth of the member? Breadth of the plate is how much? 200. 200 minus how many holes are here? 3 number of holes. In a plate you have 3 number of holes. So you should subtract that and multiply by the thickness. What is the thickness? Thickness of the plate is 10 mm. You should take 10 mm only. Okay. Now your solution will be 0.9 into breadth fraction. So you have 3 number of holes. Total breadth is 200. You subtract 3 number of holes, you will be getting the net breadth. Breadth into thickness. What is the thickness of the least plate? 10 mm into FU. Ultimate strength of plate is 410 divided by 1.25. 395 kilonewton. What is the least strength in these three? First, if the joint is failing, either bolt will fail or plate will fail. Plate will fail. Which plate will fail? The smallest 10 mm plate will fail exactly at 395. Next, which will fail? Next the bolt will fail due to shear or bearing. Then after that the third number of failure, if it goes beyond, then it will be shear. Therefore, the design strength of joint is 395.56. What is the difference between lap joint and butt joint in designing? Shear strength of bolt, for lap joint you don't have this component, that is shank component is not there. You check it. For the lap joint, the shank component will be 0, only one component will be there. But in case of butt joint, you will be having both the shank portion as well as the thread portion. You will be having two number of components. And which is most efficient, lap joint or butt joint? Butt joint is the most efficient. Yes. Now we will be going into brackets. So this is the third case. What do you mean by bracket is? This is a member. This separate member is called as bracket. This will be provided in a column. This is bracket plate, and here you will be making any bolt connection or weld connection. So in a column, in gantry girders, in number of girders, or in tall structures, in many of the monumental structures, you will be having a column with the bracket. The beams will be placed exactly on the bracket. Bridges also you can see, there you have a small bracket at the place where you have retaining wall. See, the highway lines are there, you are having hammer piers. At all the area you are having hammer piers. But you will be having one retaining wall portion, where in that retaining wall portion you will be having this kind of bracket. So those are all concrete bracket, not steel. Here whatever you are designing is a steel bracket. A long column will be there and the bracket portion. Above that the beam will be placed. So this is the portion where you will be having the beam. This component you are going to design now. For designing that, what are the additional things you will be getting is, since you are providing this beam, you will be having moment at this section. So if you are having any member like this, any projected member, this is a projected member, you are applying a force here. What will happen? Moment will be there. So in a bracket connection, apart from shear, you will be having moment also. Okay. Now for tackling that, you have the additional three formulas. You can solve the problem. F2 is K into R. What is K? Is a constant. P into E. P into E is moment. What is P? Is a force, and E is the eccentricity. What is eccentricity is? You will be having line of action along the column. If you have a column, the neutral axis will be there at center. What is the distance between the neutral axis to the extreme point of load is called the eccentricity. How to find moment? What is the formula for finding moment? Force into distance. So you will be having P. What is the distance here? 250. So if you want to find moment, simply you have to multiply force into the distance. For direct shear, how to find direct shear is force divided by N. What is N? Is number of bolt. See, if 100 kilonewton is being applied here, if you are providing 5 number of bolt, each bolt carries how many kilonewton force? 20 kilonewton of force, that's all. If you are providing 10 number of bolts and having a 100 kilonewton load, how many force will be carried? 10 kilonewton of force in shear. This is for direct shear and for bending shear. So you have two types of shear, one is direct and another one is bending. For finding direct shear, you can find it by force divided by N, whereas N is number of bolt. For finding the bending shear, you have K into R. What is K into R? Is P into E. This is your formula. P is the force, E is eccentricity, and R is the radius. What is the radius of the R? Is from the center of the bolt, if you are having a joint like this, it might be a total distance of 400 mm. Your centroid will be at 200 mm. From the center bolt, what is the radius of extreme bolt? That is the place you will be having maximum shear. So at the center bolt you will be having minimum shear. To find the maximum shear, for that you have this formula, that is R divided by summation of R square. This is your formula. Now how many number of bolt is required? How to find that? M equal to bending moment. M equals bending moment